Hello IT pros and devs. Welcome to the session. A big thank you to our sponsors and of course the team that made this bringing together the community, even if we are remotely. I hope you are all okay and staying safe. My name is Panagiotis Tsoukias. I'm a customer engineer at Microsoft focused in IT operations management. And today I'm going to talk about patch management. The contents of this session, we're going to do a quick overview of the update management solution in Azure, see the components of the solution, and demonstrate how we can deploy and configure it, and of course how we can gain visibility through reports. So this is the world that we live today. We have a shift of IT control from on-premises to a hybrid multi-cloud scope. Ever-evolving cloud-native solutions are there to provide visibility and controls to improve an enterprise's security posture beyond what is possible with on-prem tools. What we need is update management at scale. A built-in solution supporting either Windows or Linux across environments. Key scenarios that we need to cover is to answer what updates are available, perform the updates in an automated way at scale, and ensure the compliance. The assess means that we need to be sure about the status of the updates on each server. Then we need to deploy the updates with our own custom approval criteria in an automated periodic deployment. And of course, be able to verify the update compliance and across the environments. And the circle goes on. The Azure Update Management solution is not an update repository. The servers need to be configured to communicate with the update catalog for Windows or an update repository for Linux, either private or public. Each server needs to be connected to a local analytics workspace, and this means that the local analytics agent is present and the service configures it as a hybrid runbook worker, meaning it can run scripts locally. For interconnectivity, we can leverage local analytics gateway in order to provide this outgoing traffic to the configured agents. The Log Analytics is a collection analysis service for Azure Monitor Logs. It provides out-of-the-box a lot of solutions that can help us with data collection, analysis and correlation of the data, and provides also rich visualizations. The workspace is the management boundary, meaning that it collects all our telemetry and it lives and breathes inside, providing us powerful search and analysis capabilities using the Azure Query language. Azure Automation is a cloud-based automation configuration service and supports management of resources across Azure and non-Azure environments. The Update Man solution supports a variety of OS flavors, multiple versions of Windows Server starting from 2008 R2 and later, And of course, a lot of distros for Linux. You can always consult the online documentation about the OS versions that are supported. Let me walk you through our demo environment. Here we have some on-prem VMs configured in local Hyper-V. They're both, some of them are Linux and others are Windows. They are configured to be connected to a local Linux workspace via a gateway, a local Linux gateway. And also we have some Azure VMs. We can verify the connectivity to the workspaces by querying the heartbeat table. And here we can see the last heartbeat of each agent. Alright, so let's move on to the actual demo. I will open up here my Visual Studio Code. I have already configured an Azure DevOps project, and this is the Azure pipeline that basically executes a PowerShell script and deploys the solution on Azure. Let me just go ahead and trigger this one. So I will start deploying. So my test here, deploy right? And I will push the changes to the repository. This should trigger my pipeline. No, this is a different run, so let's go here. Right, so my pipeline is already running, and let's see more details here. Okay, it is checking out, and let's wait for this to finish. In the meantime, I will walk you through to what it does. Basically, it is a resource group deployment, and it deploys an ARM template defined here in this JSON file. And the main component, of course, is the workspace and the automation account with the update solution. Also in the template, we have parameters for the software update configurations, those being the configurations of the updates, of the deployments of the updates with their own schedules. So these are some examples. The JSON file exposes parameters that we can use to specify schedules dynamically. Okay, so let's see how our template is doing. Right, it's already deployed it. Perfect. So let's go to Azure, and here is the resource group that we performed the deployment, and here are the resources. Okay, so in order to onboard VMs, we need two pieces of information from the workspace. Onboarding meaning installing the engine and configuring it to report to the workspace. So I have here an artifact that basically is the output of the deployment, and we can fetch that one, and let's see if it opens up, right? Okay, so this is just an example of what can be achieved. So we need the workspace ID, which is this key, and the one of the keys for the workspace. So workspace ID and key in order to onboard the agents. Okay, so let me go back and here, yes, we can see that we have a couple of options for many options actually for deploying the agent. We can do it manually or we can do it programmatically. Either case, we need this workspace ID and key. For Linux, we can use a wrapper script. You can find it in GitHub and referenced by the local analytics agent documentation for Linux. For Azure servers, we can use the VM extension, and here is the JSON schema of the VM extension in particular. And of course, we can do it programmatically with Azure CLI and Azure Parcel. We can do it manually. Easiest way to go directly to the workspace and add the VMs as data sources. After the agents are connected to the workspace, we can verify the heartbeats. One heartbeat is sent every minute from each agent, and we can gather the last generated heartbeat, and we can verify, in this example, the heartbeats of the latest heartbeat in the last 5 minutes of every machine. Our workspace is configured with the automation account, the update management solution, so we are expecting that if everything goes well, that our machines are going to be included in the scope of the solution. The update deployment configurations is the resource inside the automation account that allows us to configure options about the update deployments. Options like which machines to update, either explicitly defining them or creating dynamic groups, selecting the update classifications, or maybe including or excluding specific updates, the schedule, of course, and it can be an advanced schedule also, and tasks that can be run before or after the update. Those can be scripts defined in the automation account, and they can be called before and after the schedule. We can also define the maintenance window, meaning how much time the deployment has in order to deploy the updates, and what will be the reboot behavior. In order to deploy these update configurations, we can use an ARM template, and this is what we are doing in the example. And of course, use PowerShell or direct calls to the API. In the portal, we can have historical data about the deployment runs. And if we click in an individual one, we can see details per deployment run, and we can click on a particular machine, and we can see deployment details on this particular machine. So let me go back to our deployed resources, and we can see that we have our deployment schedules deployed. Let me click on this one. So this is a Linux update deployment. We have configured here via the template two queries, one for Azure VMs, one for non-Azure VMs. And if we click preview on the safe search, which is non-Azure one, we can see that the query will include machines to the deployment run that are Linux and are reporting to this particular workspace. So for Azure VMs, we can click on preview again. We see here the options of the query. We define machines here that are in this particular subscription, and they have a specific tag. So let me show you from code. All right, so where is it? Here we can define the Azure query. We have the scope of the subscription scope that is calculated at runtime, at the deployment time of the template. And here is the tag filter. So the tag name is update ring, and the value is coming from our parameter file. So if we go to the parameter, we can see here our defined value. One for the Windows one and one for the Linux one. So let me copy this, and so this update ring Linux one, and we need to find a VM that is reporting to this solution, that is Linux, and we need to change the tag. So this is the machine that we have, and I have it open here. All right, so the name of the tag, as we said, is update ring, and the value is, let me copy that one, Linux one. Okay, and click apply. So now my machine should have the tag, right? And I can go back to my deployment schedule, Linux one, see the query again, and should come up. Let's refresh a little bit. Okay, here it is. So you understand here that we can give flexibility to the teams responsible for this particular VM by defining a value themselves. They can define a value in the tag of the machine, and it will be automatically included in our update schedule. Moving on in the last bit of our session, single pane of glass. What do we mean about it? So we find ourselves in a situation pretty quickly that we need to query the update manual solution and gain insights across our infrastructure. So in our example, we have workspace 1 and workspace 2, and we can configure Power BI to directly query them and gain our insights, gather our insights. So here is in the portal the update solution from one workspace and the update solution on the other workspace. Separate workspaces, meaning separate telemetry, separate update management boundaries. And of course, we're gonna sooner than later find out that doing this for multiple workspaces is very difficult. So is there a way to do this programmatically and across subscriptions? Yes, the answer is a unions workspace. Basically, what we need is a middleware where we can query directly, and execute union queries that concurrently query across the workspaces. So basically, a union's workspace is a workspace with no telemetry data, just configured functions that are based on the union function in the custom query language. And you can see here in an example, we define the table update as a union between those two workspaces. So let's see how we can do this programmatically. Here is the pipeline that is responsible of deploying this union workspace. The pipeline executes a PowerShell script that gathers all the required information to pass it through to the ARM template that deploys our union workspace. So here it's called, the template is called deploy management workspace, the workspace containing the functions. Data for our workspaces that we're going to include in the functions are coming from a resource graph. So here is a query, and let me show it to you through the PowerShell scripts. Here is the query that we can execute against the resource graph, and I have it here in my environment. So we query for resources of type operational insights workspaces, and we gather information like which subscription they belong to, resource group, the names, the display names, and the ID. So if we run this, right, of course failed, we can see all the workspaces that we have here. Back to the script. The script queries each of the returned workspaces about their schema, and if the update solution is installed, it is being included in our union functions down below here. So basically it is a mechanism that we can dynamically include workspaces in our union functions and subsequently include them in our reports. The end result is, of course, our Power BI report, and here is an example. So here I have a Power BI report published in my workspace. The first page is about information coming from the heartbeats. I have here a slicer. I can filter, I can focus on particular workspace, right? So if I choose the Azure one, I can see that I have two VMs here. If I choose the other one, I can see that I have my on-prem VMs also with the SureSet machine that we saw earlier. Going to the update management page, I can query the workspace, both the workspaces at once, and correlate all the information in the corresponding tiles. So you can see here a computer summary that all my computers are 8. 5 of them are assessed, 3 of them are not. I need some updates. Critical security ones in particular are the most important ones. I can see a pie chart here about the distribution of computers by OS version, classifications, and some information. -1 here meaning that this particular machine did not have the update agent ready to assess. So probably we need to investigate about and troubleshoot the agent. Again, here we have the slicer, and we can filter out, we can focus on the particular workspace. Clicking on classifications or filtering out by OS version. Lastly here, a page about missing updates. We can investigate and report upon particular updates that we are missing. Let's see that we have our Linux VMs are missing those ones, or Windows are missing those security updates. Alright, so let's go ahead and deploy this workspace as a middleware. And here's the pipeline. Let me, yep, there's a CI trigger, so wherever I need to change, save it, I can commit it. And push the change. So if I go to the DevOps project now, okay, it is finishing, so I can see the published artifact here. Okay. So the query, the Power BI queries need to target this particular management workspace. And if my queries are calling functions that are available, I will get results from all the workspaces. And I can demonstrate this from Power BI. So I have already here a template that I can open up. And the first thing that it will ask, of course, is which workspace to query. And it accepts the workspace ID. Right, so here we paste the workspace ID, the workspace that we deployed, and we change the time range to something meaningful, and we let it load. And after it finishes, let's wait a little bit. Right. Okay. It should start in a moment. Okay. So let me open those. So yes, so here is the actual execution of the queries. I have now live data here. I can publish this report, and if I need to change any options or parameters, I can go to the transform data and change my queries. So here is I can show you an example. If I go to the advanced editor, you can see that Power BI queries are directly against the log analytics API, and it is waiting here the workspace ID to execute the query on. And here is my query where I call the function that contains the unions of the heartbeat tables. The result being getting data from all the workspaces included in the function. This concludes our session. I hope that you found it informative and interesting. I'll be online at the time that you watch this for your questions. Thank you for watching and take care.